Now we get to trapezoids and kites, which are going to be our non-parallelograms we look at in our quadrilaterals unit. So let's start with the trapezoid. A trapezoid, by definition, is going to be a quadrilateral with one pair of parallel sides. A parallelogram would have two pairs of parallel sides, two sets of parallel sides. This one only has one. So it has that parallel part, but not both parts. It's close, kind of half of a parallelogram. So what we can get from that is that supplementary angles for same side interior angles, so I'm talking about these two here, would be supplementary. These two would be supplementary. Here again, and here again. So other than the parallel leading to angles, our angle rules with parallel lines, that's really all we get with the trapezoid when it comes to solving. An isosceles trapezoid is going to have a little bit more. So an isosceles trapezoid is going to be a trapezoid, so it still has the one set of parallel sides, but it also has one pair of congruent sides. Now these are not the parallel sides, these are the non-parallel sides. We're going to call these legs, kind of like an isosceles triangle that's been stretched out. So this one pair of congruent sides, we call legs, makes it isosceles. We also get that diagonals are congruent, similar to a rectangle. The full diagonals are congruent. And the base angles are congruent, and that would be angle A and B here, as well as angle D and C. So it gives a little bit more to work with, especially when we start solving and looking for angles and sides. What we get also for both of these is the mid-segment of a trapezoid. This, we've seen mid-segment before whenever we've talked about triangles. This works for any trapezoid. The mid-segment is the segment that connects the midpoints, and that's going to be the midpoints on the non-parallel sides. And that mid-segment is going to be the average of the bases. It's kind of in the middle of the two bases, so we find the average of them. So you're going to add the length for the bases, divide by 2, and it gives you the mid-segment. This isn't a specific property. It doesn't show up to guarantee it's a trapezoid. It's just another type of problem we might see. The last shape we have is a kite. Now a kite isn't going to have any parallel sides. It's got a little bit more to its definition. So it's a quadrilateral with two pairs of consecutive congruent sides. So I have two pairs of congruent sides here and here, but not opposite sides, because if the opposite sides were congruent, then it would be a parallelogram, and this is not. What this could be related to is it's almost like we took part of a rhombus and stretched it out to one side. So it's kind of a stretched out rhombus. But most of us would know what a kite is, because if you drew in the other line here, it looks like a kite that you would go fly with its little tail flying through the air. Okay, other things that we have is diagonals would be perpendicular, and it has one pair of congruent angles, and that's those angles that are in between the different length sides. So some symmetry there if you were to fold it in half and match up. So let's go through and just kind of work through some different problems where we have our trapezoids and kites. So we have an isosceles trapezoid. MP is 16x minus 13. We have NO is 9x plus 8. PN is 5y plus 19, and MO is 12y minus 37, both of those being diagonals. So to solve, I can say that the 16x minus 13 and the 9x plus 8 are equivalent because they're the legs, and the legs are congruent. So we'll go 16x minus 13 equals 9x plus 8, gives us 7x equals 21, and x equals 3. For the diagonals, since diagonals are congruent, they don't necessarily bisect, that would be in a parallelogram, but they are congruent. We could say 5y plus 19 equals 12y minus 37. We're going to subtract 5y and get 7y. We add 37 and we get 56, so y equals 8. So that's kind of solving for sides and diagonals in a trapezoid. The next problem involves a midsegment. So we have midpoints, which means we have a midsegment, and we need to find not only the length of the value of x, but we need to go back and find uv afterwards. So the midsegment, 8x minus 3, is equal to the average of the bases, x plus 7 plus 6x plus 5. Now average means we divide by 2 here. So we got 8x minus 3 equals 7x plus 12 over 2. Now I don't want to take half of 7x plus 12 because 7 is an odd number. So instead let's multiply the 2 over and get 16x minus 6 equals 7x plus 12. We can then subtract 7x, we get 9x on the left side. We then add 6, we get 9x equals 18, and x is 2. Now it's asking for uv, but let's find the other values first. If x is 2, this is 9, and 17. Now 9 and 17, if I average those two, 9 plus 17 is 26, half of it is 13, 13 is in the middle. We could also say, well, 9 and 17 are 8 apart, halfway would be 4, and that would be 4 from each would be 13. So this idea of it being in the middle is really what we're looking for. And if we go and substitute the x in for 2, we also get 13 for uv, which is our answer. But it does fit into the problem that it should actually be within the middle. Next problem. I have an isosceles trapezoid. I have to find the missing angles. Now, these are opposite angles. I don't know much about them, but I know base angles are congruent. So 10x plus 5 is w as well as x. Then I have same side interior angles. So I know that the measure of angle x plus the measure of angle y has to add to 180. So we're going to say 10x plus 5 plus 6x minus 1 equals 180. So that's 16x plus 4 equals 180. 16x equals 176. 176 divided by 16 comes out to be 11. Now we're going to substitute that back in to find our values. So we have 6 times 11 minus 1. That looks like 66 minus 1, or 65. Then 10 times 11 plus 5 is going to be 110 plus 5, or 115. So we have 115, 115, 65, 65, but also 115 and 65 also add to 180. So W is 115, X is 115, and the other two being 65 degrees. Next problem, it's another mid-segment, so we're going to go 5x minus 19 equals the average of the two, 38 plus x plus 14 over 2. 5x minus 19 equals 52 plus x over 2. I'm going to multiply the 2 over and make it 10x minus 38 equals 52 plus x. Subtracting x, we get 9x. And adding 38, we get 90, so x comes out to be 10. Now to find yz, we substitute 10 in, we get 50, minus 19 is 31. Now, 38 and 31 are 7 apart, so if I did this correctly, I should be able to subtract another 7 and get 24 here, which it does in fact become once I put in for x equals 10. The last one is we have a kite. Now, in a kite, we know diagonals are perpendicular, and we know these opposite angles match. So I could do 90 minus 37 to get 53 here. It's a right triangle. And then this will also be 37. We get some right angles. So let's see if that's enough. PTQ is 90 degrees. PQT is 53. And then QRT was 37 degrees.